Hello, I'm Jenny, and this is Live, Laugh, Lava, a podcast where I try and learn you a geology thing in 5 minutes. Today's episode, Foraminifera, tiny thermometers of oceans past. Here's a scenario for you. If you wanted to go swimming in the sea today, you'd want to know how warm or cold the water was. And that's very easy to find out now with a thermometer. But what about a time before thermometers were invented, or even before humans existed? How do we know how warm the oceans were millions of years ago? This is something that scientists have been looking into for years. Scientists who research this are called paleoclimatologists. This just means old climate to you and me. One of the ways these scientists are trying to figure out the temperature of our oceans in the past is by studying fossils. Now I know that when I say this, most of you will be thinking about dinosaurs. But the kind of fossils that I'm talking about are much, much smaller. In fact, they are so small you need a microscope to see them, which is why we call them microfossils. The type of microfossils that I want to talk about today are Foraminifera, but we can call these forams for short. They are single-celled organisms, and some species can still be found alive today. They're very useful to scientists because they are found in their millions all over the world, preserved in the mud found on the ocean floor. This makes forams much easier to find than dinosaur fossils. But how do we use forams to understand ocean temperatures of the past? The answer lies in chemistry. Stay with me, it's not as complicated as it sounds. The shell of a foram, or the test, is made of calcium carbonate, which contains calcium, carbon, and oxygen. The interesting thing about oxygen is that it has different isotopes, where the nucleus of the atom has the same number of protons and electrons, but different numbers of neutrons. Oxygen-16, for example, is the lighter version, with 8 neutrons, while oxygen-18 is heavier, with 10 neutrons. This means that more oxygen-18 is incorporated into the shell of the foram. Paleoclimatologists can measure this as a ratio of oxygen-18 to oxygen-16. This is achieved using a technique called mass spectrometry. Over time, as the ocean temperature changes, the ratio of the different oxygen isotopes will change as well. So by looking at forams of different ages, we can see how an ocean has got warmer and colder over geological time. So now we have an understanding of how scientists use forams to collect information, but what about different types of forams? Scientists have realised now that different species of forams can give us more information on oceanic conditions in the past. Different Foraminifera live at different depths in the ocean. For example, planktic Foraminifera will float in the water column in their life, and this can give us information about surface water temperatures. Additionally, this can be used to understand how ocean currents were operating in geological history. Other forams, rather than living in the water, live on the sea floor. We call these ones benthic Foraminifera. They help us to interpret bottom water temperatures, which can be used to contrast against surface water temperatures from planktic forams. While all of this is interesting in its own right, the information collected by paleoclimatologists is invaluable. By making inferences on the climate of our Earth's past, we can gain a greater understanding of what is likely to come in the future with regards to global warming and climate change. Well, that's all I've got time for today, but I hope I've convinced you that microfossils are just as exciting as dinosaurs. I've been Jenny, this has been Live, Laugh, Lava, and I hope you'll tune in again next time. Bye for now.